All right, ladies and gentlemen. Now we've got Craig, talking about how I auto-refactored a huge open source software project to use Pytest.
Thank you. Hi, my name is Craig Stigter. It's great to be here. This is my second PyCon AU and my first presenting. And this is about a journey that I went on last year through the depths of automated refactoring in Python. I've been working at a company called Coordinates for the last 11 years, which is a while now. And I'm still there because it's basically my dream job because I get to play around with Python all day, every day. And also it's something to do with GIS data, and that's cool too. In that 11 years, I've played around with tools like 2 to 3 and Futurize, some of you might have used, and Black more recently. Who's used Black here? Cool, that's good. If you haven't, you should. It's really good. And the thing that Black does is it reformats your code. And it does so without asking you many questions. And in fact, it's very unconfigurable. And that's good because formatting code is boring and no one cares about it. And so it's nice to just have it turn some ugly code into some nice code, and just, you don't have to worry about how your code is formatted anymore. Black takes care of it. And when I switched to this a few years ago, I thought, that's so cool. That's such a cool thing that it can understand my code and it can safely reorganize it for me without me having to think too hard about it. And what if I could do something like this? What if I could write code that rewrites my code? Maybe I could do something awesome with it. And that's about where I left that for a while. It just bubbled up in my head, and I thought, that's cool. I could do something like that maybe one day. And the specific thing I wanted to do at the time was we had a big test suite which was written using the standard lib unit test module. So it had unit test.test case everywhere, and that was fine for a while. But then we switched to Pytest, and Pytest is awesome. And I wanted to kind of rewrite our tests to a Pytest style. Who's used Pytest here? Excellent. If you haven't, you should. It is also awesome. And what Pytest does is, here's 2 tests side by side, and the one on the left is an old school, standard lib unit test thing. And it kind of looks a bit like Java. And the one on the right is a Pytest test. And it's shorter, it's a bit prettier, it's much more flexible. And we'll go into that maybe a little bit, but not right now. And so, and the other thing I should say is that Pytest, the test runner in Pytest is backwards compatible with these old unit test cases. So it will run those for you. So if you switch to Pytest, you don't have to immediately rewrite all of your tests. It will mostly run them as is. And so we switched to Pytest, and we had all this old stuff lying around that we didn't touch because it would be a massive effort to rewrite it. But it bothered me. And every time I had to interact with one or change something in one, and I had to type self.assert equal or whatever, or just even see that on my screen, it really irritated me. And I wanted to change it, and I wanted to fix it, but it was never worth the time commitment, because there are thousands of these. Yeah. And then I went to this talk last year at PyCon AU. This is a talk by John Reese at Facebook, and he did this talk on refactoring code with the standard library. Did anyone else here go to that talk? Yeah, a few people. If you haven't, and you're interested in this stuff, I recommend it because he does a much more gentle introduction to automated refactoring, and he covers a lot of things I'm just going to gloss over. And this is so John Reese and Facebook released at the same time a library called Bola. And it essentially is a library that you can use to write scripts that modify your code. And so he gave this example on his website. And he wanted to look for comments that say to-do internationalization, followed by a print statement. And he wanted to automatically add a translation function to the print statement and remove the comment. So that's he wrote some code, and he ran it, and it did that. And I thought that was cool, and I went off and downloaded Bola and played around with it a little bit. And I made a few easy wins for our code base. I don't know what I did immediately, but maybe I replaced self.assert equal with a normal assert statement. And I thought that was cool, and I mentioned it to Rob, the CTO of Coordinates, and then I went to bed. And then I woke up in the morning, and Rob had just casually volunteered me on this massive open source project to work on their test suite. Thanks, Rob. And this project was called GDAL. I don't expect a lot of hands, but has anyone here used GDAL? Yeah, there's a few. OK, more than I expected. GDAL is GDAL. It is the Geographic Data Abstraction Library. And that's a bit of a mouthful, but just call it GDAL. And working at Coordinates, we do things with geographic data, and hence we use this library quite a lot under the hood. And it's a big C++ thing, and it has Python bindings. And so almost all the tests are written in Python. And in great fear, I did a line count on the Python test suite and found out it was 271,000 lines of code. So what's wrong with them? Why do they need refactoring? Because I was like, I don't know, it sounds interesting, but this is a big project, probably. What was wrong with them? Well, they're 20 years old to start with, and they did not use the unit test library in the standard lib, or Pytest, or anything fancy like that. They were just using a homegrown, in-house thing that was built by C++ developers. And nothing against C++ developers, but a lot of it was not very Pythonic. There was a lot of boilerplate. It was very hard to drill into failures. So if you had a failure, how would you isolate that failure and run it by itself over and over again while you iterate on a fix? It turns out you can't run an individual test in the old test suite. You could run the file that it's in, but if the file had 100 tests, you're running 100 tests. And if it's slow, tough. There was ugly output. And this last one is a problem. Those 100 tests in that file must be run in order. And the old test suite only let you run them in order. And so if the first test had a problem and didn't run, the rest would not run. And that's because the first test would do setup, and the second test would rely on that setup. So they were not independent. And this actually is something that I never fixed, but maybe, hopefully, I improved on a little bit. But they needed help a little bit. It was just a very inflexible test suite, and it needed a bit of work and care and attention. I'll give you an example. This is actually not one of GDAL's tests, but it's very characteristic of their style. I kind of made it up for a slide, but anyway, sorry. So the test does a little bit of work at the top, and then you might see that instead of an assertion or a self.assert equal or anything, it's got an if statement, and if the if statement kind of fails, it will return fail. Otherwise, it will return success. So the test contract here is that tests must return a value, and if they return fail, they fail. If they return success, they succeed. And if they return something else, I have no idea what happens. If they raise an exception, for whatever reason, the rest of the file never runs, because that was not really something that the test runner could deal with. I think it did a try except around the whole test module. So if there's 100 tests and the first one throws an exception, it will catch that and start on the next file and skip the other tests. There is some other issues here. There's this thing called GDAL test.postReason. And I guess the point of this originally was that if you're returning fail, you're kind of losing some context about what happened. This test failed, but we don't know why. So they wanted a way to add a string to that to say it failed because of whatever. And so there you can put a string, and I think it probably just ends up in standard out usually. I don't think anything magic happened with it. But about 95% of the time that this is called in GDAL's code base, it was called with the string fail. So these were not terribly helpful. And so I thought, look, if it's not being used for anything useful, let's just get rid of it. It's pointless. And same with the print statement there. That is printing something useful. I guess if that checksum thing was different than what you expected, then you want to know what it actually was, right? And there's no way to get that from the return value of this test, so we just needed to print it to standard out. And that makes sense. And if you get a failure here, you might just have to scroll up a little bit and see, okay, the CS thing was 1, 2, 3, 4. That makes sense. And there's one more thing that I don't like about this test, and that is the GDAL.unlink down the bottom. It's, I guess the first line of the test creates a file, out.tiff, and the last line of the test there, before it returns, is cleaning up that thing. It's deleting it. So if this test failed, or if it threw an exception, that file would never get cleaned up, I guess, until the next time you run the tests and this test passes. And I just don't think that that's something that tests should need to take care of themselves. So I would like this test to look a bit like this, down the bottom there. So I'll just say what's good about this. One is, obviously we've turned the if statement into an assertion. We've gotten rid of the return values. Now the test contract is, if this test raises an exception, it failed. Otherwise, it worked. There's no return values. GDAL test.post reason went away because it was pointless to start with. The print statement, if you're using Pytest for this, the print statement is actually not needed anymore. And that's because Pytest does a little bit of magic here. If you have an assertion and the assertion fails, Pytest will print out the values of all the expressions and sub-expressions in that assert statement. So Pytest will say, assertion error 1234 is not equal to 4783. So we no longer need that print statement to print out that CS thing. And there's one more change here. That GDAL.unlink has disappeared. And I've gotten rid of it because you might see that little temp_dir argument to the test. This is what's called a Pytest fixture. And there's some built into Pytest, but you can define your own ones. Really easy to make. And a fixture is just basically some code that is guaranteed to run before and after your test. So it can, in this case, what it would do is make a directory in the current directory called temp. And then once the test is finished, whether it succeeded or failed, it will remove that directory, including all the contents. So that out.tiff has just disappeared. I like this test much better. It's prettier. I don't have to think too hard about it. It just kind of does what I want. So I'd just like to point out, you will never be able to do this with a regex replace. You can do that manually easily, but if you try and do this with a find and replace on your code base to change 1,000 of these at once, good luck. It's really hard. I don't care what kind of regex wizard you are, you're not going to be able to do that. So we need something better. And what we need is syntax-aware refactoring. We need basically a find and replace for structured data. And the structured data here is a Python syntax tree. And it turns out that Python defines a pattern grammar for doing syntax searches on Python syntax trees. So it's a complex thing. Python actually defines not only a syntax tree, but it defines a grammar for a language you can use to search that syntax tree. And things like, and the lib2to3 module in the standard lib implements a bunch of functions around that syntax. And bola uses it, and black uses it. So I'm going to go through this. This is essentially a little find and replace. I'm just going to try and remove just one feature of that test there. I'm just going to get rid of the GDAL test.postReason call. So we'll go through this. We're creating a bola query. So this is the library that Facebook released. And the bola query is going to look at some Python files. And that select there is we're going to look for a pattern. And this isn't a we're not looking for some text. We're looking for some nodes of a syntax tree. And once we've found those nodes, we're going to call modify on it and pass it a callback. So that callback is going to make some changes to the syntax tree, and execute just says just do it. So I'll ignore the callback for a sec. Let's just go back to this pattern. Because it's complicated, it looks very complicated. It's actually very easy to learn. What we're looking for here is a simple statement. The angle brackets just denote nesting. So this is a tree of stuff. And yeah, we're looking for a simple statement that contains one function call. Power there just means function call. I don't know why they called it power. A function called to GDAL test.postReason with one string argument. So yeah, that's what we're looking for. So we're looking for a simple statement that contains one function call to GDAL test.postReason with one string argument. And I'll just point out that we are capturing the string argument into a variable called reason. This is a little bit like a regex, like a named group in a regex. So we're looking for this thing, and then we're just going to capture that string argument into a thing called reason. Right, now that we've found that, we've called select and given it a pattern. We've found some nodes, hopefully, in our Python file. Now we're going to pass them to our callback. Now a bola callback takes 3 arguments. It's got the node, which is the outermost node of our pattern. In this case, it's the simple statement node. It takes capture, which is a dict containing anything you captured. So in this case, that will just include the reason string. And it takes a file name, the Python file that we're operating on. So this function that I wrote just looks at the reason. And if the reason is fail, it removes the entire statement. Cool. There was a lot to unpack there. This is what it does. Boom, got rid of it. Yay. And you might say to me, that was a lot of work, dude. You're right. But then I ran it on the code base. And that got rid of almost 9,000 lines of pointless code, just that little thing that I just wrote. And I was like, really, wow, this is amazing. I got really excited, and I went a bit crazy, and I just wrote this for everything. And I'll just whip through some of the other things. Pytest expects tests to be named test something, and the tests weren't already. So I made some logic which looked for nodes that were functions and looked like tests, and were not already named like that, and I just renamed them. I got rid of those fail and success return values. Took quite a bit of work to cover all the different cases here. But it was worth it because the diff from just this was about 50,000 lines. So it saved a lot of pointless code, and I made things a lot prettier just by doing that. I found a lot of things that were doing try excepts just to make sure an exception happened, and if it didn't happen, then it was a failure. And I just replaced that with pytest.raises because that's what it does. And I did a lot more, and I kept at this every night, often for hours. And it was really fun, and I loved it. And my wife didn't really appreciate it. It was borderline obsessive. Okay, it wasn't really borderline. And my wife was unhappy. She was not impressed. But this stuff was just so cool. So I spent hours every evening on it for ages. And in the meantime, GDAL kept going. What a surprise. And GDAL is a very active project. Okay, it's not the Linux kernel. But you can see 1 week there they had heaps of commits, but maybe that was a sprint or something. But most weeks they would do 20, 30, 40 commits. And almost every commit touches the test suite. That's a good thing, probably. But since I was basically rewriting the test suite, almost every commit conflicted with what I was doing. So I couldn't possibly keep up with that, and I couldn't resolve all the conflicts. So I needed a strategy for avoiding conflicts. I needed a way that I could say, okay, look, there's a million conflicts here, but I don't care. It doesn't matter. And I came up with a few rules to avoid those conflicts. First one was I should keep my manual changes and my automated changes separate. I didn't, I say I was doing an automated refactor, but there was actually quite a bit of manual stuff that I needed to do or just wasn't worth automating, or like I had to write the fixtures that my automated changes would use and that kind of thing. So I did have a bunch of manual commits, and I had to keep those completely separate from my automated commits because I was rebasing my stuff on top of upstream. And I was rebasing, these points are probably in backwards order really. I was rebasing because I had to rebase. I wasn't merging. I don't know if you are a Git expert or whatever, but sorry about all the Git stuff. I was rebasing because I had to rebase, and the reason I had to rebase was the only way I could avoid conflicts was to not try to resolve conflicts. It turns out that resolving conflicts on automated commits is a big waste of time. If you can recreate your commit in 10 seconds by running a script, that's much faster than trying to resolve the conflicts. So what I would do was I would rebase my initial manual commits on top of whatever was upstream. And then I would just recreate all of my automated changes on top of that. And that took a while because there's a lot of files involved, but like a few minutes. And then I would maybe apply a couple manual changes on top of that. And I would do this every day. And the final rule I'll say is I had to prevent myself from fixing everything because I knew this was going to be a big change. And every change I make was a potential conflict with something that someone else was going to do. So I had to physically restrain myself almost because there's just so much that needed fixing. And I was like, I must fix it, I must fix it. No, I'm not going to. So all this rebasing and stuff took time. Like I would sit down to do some code, and I would first have to pull in the latest changes and figure out how to rebase things. And like I'm a programmer, and I hate doing busy work like that. So I wrote a script to do it. It was a bash script, not a Python script, sorry. But essentially, it called my Python script a lot and committed the changes for me. And it did this. And it's just applying all my automated changes there one at a time and committing them to the Git repository. And any second now, boom. And all that stuff at the end is just cherry picking a bunch of manual commits that I'd already done on a branch. So did all the automated changes and then added all the manual stuff on top. And that was so satisfying to watch. This is the script, more or less. And it just, it goes through a bunch of commits, gets some commit messages from somewhere, applies the changes, commits them, and then down the bottom there just cherry picks a bunch of manual commits from another branch. And and every time I ran it, I just felt awesome. So at this point, I'm going to just say some things about when this is a good idea, because I think usually it's a terrible idea. It's a good idea if you're working on very large projects, where it is, where it's worth the effort. If you can write your automated change and make it a massive difference, then you maybe should do it. It's a good idea if your code is very well tested, like if you're refactoring a test suite. If your code is not well tested, you're going to end up with a 50,000 line diff, and no one, let me tell you, no one is going to look at your change. No one cares. They don't care that much anyway, because that's a lot of lines, and it's going to take them hours and hours and hours. So the only thing that's going to look at your code is the test suite. So if you don't have a good test suite, don't do this. And it's a useful thing to do when you cannot use a regex. But mostly you can use a regex, and it will be safe enough. especially if your test suite is good. If you have to rename a function and all the places that call that function, then maybe you can do that with a regex. So don't bother with this stuff. Anyway, I got here. Now, I told some people 100,000 lines changed, and I guess that's if you add the additions and the subtractions, which there's various ways of doing this. It's okay. Don't fret about it. So my PR was big, and how do I get this baby merged? Because no one can review this. They just can't. So I'm just going to stress again, I had to keep the automated changes separate, not just because of conflicts, but also because that way on GitHub, someone can look at an automated commit, know it's an automated commit, look at the first 10 lines and say, oh, I know what this does. I'll skip the remaining 20,000 lines. And it makes it much more reviewable. And the other thing was I had to keep my commit history sane. And I was rebasing anyway, so I just made sure that I sort of squashed bug fixes into the commit that caused the bug so that people could look at an individual commit, hopefully a manual one, and just like not have to say, oh, look, you've got heaps of bugs here. When I'm reviewing on GitHub, I like to review a whole pull request at once, but obviously that was not possible with this. So you need to be able to look at an individual commit and have it make sense. So how do I get humans to merge this? I'll finish with a few tips for this. I guess be polite and humble. That probably, hopefully, goes without saying. No one wants to merge your pull request if they think you're an asshole. Get early feedback before you commit, and I don't mean git commit. I mean before you invest yourself in this project, you need to probably check the mailing list and talk to some core developers and see if it's something that they would actually care about. And in my case, they did. They said, yeah, the core developers of GDAL hated the test suite, like with a passion. And they were like, yes, anything you can do that will make that better is going to be, we're going to merge that. So that was really encouraging, and yeah. Leave out controversial stuff. There was a few things I wanted to do, but I was like, I don't know if people will think this is as awesome as I think it is. And I don't want to jeopardize my massive pull request to, I don't want there to be discussion on whether it should be merged. I want it to be obviously mergeable. Be responsive to questions, be patient, and give people something that they think is cool. And I think the little things count here. In my case, I installed Pytest Sugar in the development environment by default. And Pytest Sugar just gives you green Unicode check marks when tests pass, instead of boring white dots. And I think that helped. And voila, it got merged, which was cool. And I don't think Evan Ruel is listening, but anyway, huge thanks to him and everyone else who reviewed it. It was a good time. I would do it again. Probably. My wife might have different ideas. Thank you very much.